Hi there, podcast family. In continuation of the previous episode, number 18, which was on the specific and sensitive ELISA, SKA here in the 19th episode takes us into the applications of this technique in medicine. How ELISA is put to use to check the immune responses during conditions of disease or health depends largely on the way experts run this test in the laboratories. Why certain controls in quality and analysis is important, along with all that expert knowledge that you won't get in those textbooks, you'll get it right here. You definitely want to take notes here. Your feedback on podcast format, content, and queries are most welcome. Keep growing your immunology knowledge and keep liking and sharing these podcasts.
Hello and welcome back to Immunology for everyone. So, friends, last time we started discussing about some of the techniques done in immunology laboratory for various purposes, and we discussed some analytical techniques last time. These briefly included the principles of radioimmunoassay, where we use the radioisotope labeled antibodies or antigens for the detection of analytes in the clinical samples. And then we moved on to discuss about amazing technique which is called the ELISA or enzyme linked immunosorbent assay. Uh, Today I would like to share some of more characteristic points about this particular technique which is called ELISA. The ELISA basically was first conceptualized in the year 1971, and since then it has been evolved, and many types of ELISAs have come up depending on the sensitivity and specificity and the need of the laboratories. We already discussed about the direct ELISA, indirect ELISA, then we talked about sandwich ELISA, and we also talked about the adaptation of all these kinds of ELISAs into a competitive kind of ELISA. This was basically to enhance the sensitivity of the assay. There are so many different applications of ELISA in the clinical laboratory as well as in the biomedical research. In the clinical laboratory, we basically use it for the diagnosis of various diseases, looking at either the circulating antibodies against the infectious agent or its antigen. This all include the various infections like HIV is the first one where it has been extensively used, hepatitis B and C virus, Lyme diseases, syphilis, where we're trying to detect the antibody or the antigen of the ELISA. Then allergy testing, we are trying to detect the response to some allergens and autoimmune diseases diagnosis. You talk about the lupus, you talk about rheumatoid arthritis or multiple sclerosis, then cancer diagnosis. Some of the cancers, they release their antigens in circulation like CA125 or the prostate specific antigen, and ELISA comes out very handy as a very sensitive technique for detection of very low quantities of circulating antigen, including the hormones or the cytokines, and then drug level monitoring. So depending on, since it was developed, it was initially, it depended on the antigens which were made from the whole cell lysate, like whole viral lysates or whole organism lysate, which will include many antigens, which are coated onto the plate. And then that organisms, they share antigenic determinants between their related organisms, and those kind of ELISAs which were called the first generation ELISAs, they would have less specificity because of picking up the cross reactive antibodies. And then in order to improve the specificity, when the technological advancements were also made in the recombinant DNA technology, people understood how to identify specific antigens which are more immunogenic in an organism. They will induce lot of antibodies formation in the infected person's body. So those were the important antigens. So the antigens could be either isolated from the whole organism lysates or by recombinant technology. So the people started using recombinant antigens for coating the plates for detection of antibodies. And then further specificity was improved when they picked up specific epitopes or the portions of the whole protein, which is more specific for the binding to the antibodies. And so came the peptide ELISAs. The synthetic peptides are made, and these are the third generation ELISAs, which have very high sensitivity as well as very high specificity. And we do have some kind of ELISAs where you can detect either antigen or antibody. In a life cycle of a organism, the antigen basically is present in circulation only when the organism is replicating. It may be virus or bacteria or anything. If it is replicating, then the antigen can be detected, which is more specific, because even after the clearance of some of these viruses from the system, the antibodies sometimes persist for longer period of time, and antibody detection becomes very sensitive, but then sometimes less specific, because the actual active infection is gone, and you can detect the antibodies in the circulating in the serum as a part of immune response. So in that case, some of these stages of the antigen detection is more important than the antibody detection. So the ELISAs were modified accordingly, as in case of HIV infection, the or any other chronic infection where the organism or the virus is persisting in the system and keep replicating, then the antigen detection as well as antibody detection becomes very important. And in HIV infection, both the assays have got their own application depending on when you want to do it. Like in window period, you have the antigen ELISA more applicable, or in the when you are screening large number of samples in a blood donation camp, you want to detect the antigen of HIV circulating in the blood, which is more specific as compared to the antibodies. But antibodies, once become positive, they remain positive all through life, and that's how we do it. So, in biomedical research, the ELISAs are used every day in the laboratories for the detection of protein quantification, antibody detection, drug discovery, biomarker, assays, and food safety testing. Also, the ELISAs are being used. Environmental monitoring, where we check the water quality testing, air pollution monitoring, soil analysis, monitoring of industrial processes, all use these kind of ELISA systems, which are very handy, because it's normally a high throughput laboratory will use these kind of assays, which can be done like in bulk number. It comes in 96 well format, and you can do almost 100 samples every day, every run. So there are labs which are using many plates together to do it. So it depends on your requirement how to choose a specific ELISA kit, and then you look at the sensitivity and specificity of that kit. There are many advantages of using ELISA, because the protocols are very simple. They are highly specific and sensitive, highly efficient, low cost reagents nowadays, because it's being used so much that the production of reagents has come down. The cost of running each test is has come down drastically, and there are no requirements for any unsafe material like radioisotopes or which can be health hazard. But there are some limitations of ELISA, because it becomes work intensive in the laboratories where you don't have the automated ELISA machines. Then preparation of enzyme linked antibodies can be difficult, and they have to be seen that you are purchasing these antibodies from a very authentic lab, so that the specificity is maintained. And since the antibodies are unstable, so it requires a cold chain maintenance for the transport and the storage of these antibodies. When we talk about the sensitivity and specificity of any assay, you know that the sensitivity reflects a test's ability to correctly identify the individuals who have the disease condition. Like, we are looking at the true positive, and the specificity measures its ability to correctly identify those which are negative, correct, true negative. So sensitivity and specificity can be calculated very easily when you know the a gold standard can be used to look at the true positives and true negatives, and then you can calculate these by using the standard formula. And then there is a positive predictive value of a kit which gives you the false alarm rate. The higher the positive predictive value, the lower the false alarm rate. And negative predictive value basically gives you the reassurance rate. Higher the negative predictive value, you have lesser false reassurance rate of a kit. So that's how you basically uh, selected a test kit for this. Then, if there are laboratories which are doing specific test every day, we should try to quality control it and draw Levy Jennings charts. Do one control every day for 20 and take an average and draw a quality control, Levy Jennings chart, which can be seen for the performance of ELISA, in that laboratory. There are many interfering, factors in ELISA. It can be because of the plate quality, plate assay, the buffer pH can be different, or the contamination, then the capture detect antibody, incubation time, temperature, specificity, affinity of the antibodies being used, and then the cross reactivity of the blocking buffer, concentration or contamination. In fact, the contamination of any reagent should be avoided, because that is the most common interfering factor in many laboratories. Because of using the pipettes, you have to use aerosol free pipette tips, so that you don't contaminate your auto pipette, so that it is not taken to the next run. And similarly, the washes have to be very rigorously done. There should be no contamination in the buffers, and substrate quality has to be seen every day, so that the substrate is not auto hydrolyzed. It should not change color. The kits have to be stored at the right temperature, so that the and should be used within the expiry date. All these things have to be taken care before the ELISAs are done. So these are some of the points which need to be taken care when you are doing a ELISA, and you really get wonderful results from this amazing technique, which is very sensitive and very specific also. And depending on your use, you can use the type of ELISA which is important. So the message what I want to give from this podcast is that ELISA is a very sensitive and specific technique, but it all depends on how you select your ELISA, what kind of antigens or antibodies are coated, what kind of materials you are using, how you are storing the samples, how you are handling the ELISA kits, and also the quality control you are doing every day. You are trying to generate a Levy Jennings chart and monitor your ELISA every day, and then decide about the validity of a test on a particular day, to see whether you are doing a good performance. So if you take care of all these things, the ELISA comes out very, very friendly technique and gives you accurate results, near accurate results. So thank you very much.